Hello everybody, welcome to today's Maths Part 1. There's going to be another short video after this where I just show you one other style of question to help you get set up. Today we're going to be adding fractions, and it's going to bring together kind of all of the bits that you've been learning over the last week or so. There's a couple of spicy word problems in here that we're going to tackle together. So to begin with, if you want to warm up with your mental starter, please pause me and then I'll reveal the answers. Just quickly though, this top one, when it says fraction equivalent to a half, there's lots of possible answers. Just make sure you do the same to the bottom as the top. And for number 4, when it says write 500,000 in figures, that basically means in numbers. Pause me now. Right, so here's your answers. So we've got, like I said, lots of possibilities. As long as you multiplied and did the same to the bottom as the top, then your answer for number 1 is correct. Perimeter, obviously, you would do, so you might have either, it's the distance around the outside, so you might have added these together, doubled it, doubled, added, whatever. And then this bottom one, it would be 500,000 with the comma in the middle there. Okay, so let's start with a bit of a spicy true or false to get your brain thinking. So we've got 6/12 add 5 something, add 3/18 equals 1.5. This person thinks the missing denominator should be 12 or 18. What do you think? Why don't you pause me, have a bit of an explore, come back and I'll show you how I did it. Okay, so if you're looking at this thinking, oh, this looks pretty spicy, I would agree, but I think actually it looks a little bit harder than it is. It's just more steps that we need to do. So the first thing that I noticed straight away was that we had completely different, I'm going to ignore what this person's saying down here. And to begin with, I'm just going to have a think about what would I do to work out the answer to this using what I know. So if I'm adding fractions, but I've got 12ths and 18ths, I know that they're different, and to add, I need the same denominator. So if we look here, I can see I could start listing, do step 1, find my lowest common denominator, and list my 12s and my 18 times tables. I'm going to go for slightly easier than that. I'm going to go, well, actually, 12 and 18 are both in the 6 times tables. I wonder if I could divide my fractions to turn them into 6. Let's see. 6/12, to turn that into 6ths, I'm going to divide 12 by 2. And I need to check, can I do the same at the top? Yes, I can do 6 divided by 2, and I'm going to get 3. So 6/12 is the same as 3/6, which is also equivalent to half. So I'm just going to write that over here. So 3/6. Now, I'm going to do 3/18. Now, if I wanted to turn 18ths into 6, I'm going to divide. Can you remember what you divide 18 by to get 6? I'm going to divide it by 3. And looking at the top, yes, I can do the same to the bottom as the top. So I can do that. 3 divided by 3 is going to be 1. So that's 1/6. Now, because I've got 5 something, I'm actually going to turn that whole thing into just a missing number, because I'm not quite sure I don't know what my denominator is going to be. So I might need to change the numerator. So I've got 3/6 add something, add 1/6, we said, didn't we? Equals 1.5. Now, again, it's a bit tricky because I've got fractions and then I've got a mixed number. I think I'd be far more comfortable if I just had all fractions. So let's start by, I want to turn 1.5 into an improper fraction. Can you remember how I do that? I'm going to multiply my whole number by my denominator, my whole by my denominator. So 1 times 2 is 2. Then I add my numerator, which is 1. So that would be 2 add 1 equals 3. And then my numerator stays the same. So now I've got 3/2. But again, if I compare that to this fraction over here, both of these are in 6ths. So what do you reckon? Do you reckon it'd be useful if we had our answer in 6ths as well? I do. So I'm going to turn 3/2 into 6th. I need to multiply that by 3. So I do the same to the bottom as the top. And that'll be 3 times 3 is going to equal 9. Am I right? So 3/6 add something 6, add 1/6, it's going to equal 9/6. And now this should be a little bit easier. So when we add, our denominator stays the same. So that would mean 6, 6. This one's going to need to be 6. Now I've got 3 add something add 1 equals 9. Well, why don't I add 3 add 1 together? That's going to be 4. 4 add something equals 9. Can you tell me what that is? It's going to be 5, isn't it? I could always check by doing 9, take away the 4 to get it. But yeah, so 3, 6 add 5, 6 add 1, 6 equals 9, 6. Well, if we look at my fraction here then, this is going to be 6, isn't it? My denominator is going to be 6 the same way it is here. So her answer was the missing denominator should be 12 or 18. That's incorrect. It should be 6. Okay, so hopefully your brain is nice and warmed up, ready to tackle our next question. Okay. Sorry, I had to pause there. I've got my lunch next to me and a very hungry cat looking like he might try and steal it. So let's just refresh here then. Yesterday you were adding 3 or more fractions. On this, we haven't got a word problem or anything. It's a lot simpler. So I've got 3/4 add 1/2 add 7/8. Oh, I've got the answer showing. Perfect. Let's pretend we didn't see that. So I've got that. So my step 1 is I need to find a lowest common denominator. So a number that's in all of these times tables. I know 8 is in the 2s, the 4s and the 8 times tables. So that's step 1. Step 2, I'm going to convert them all into 8. So 3/4, I multiply the bottom and the top by 2 to get 6/8. And 1/2, I multiply the top and the bottom by 4 to get 4/8. So step 2 was converting. I've now got 3 fractions that have all got the same denominator. So now I can go 6 add 4 add 7 is going to be 17. My denominator stays the same, so that's 17/8. If I want it as a mixed number, I simply go, how many groups of 8 can I make out of 17? That's going to be 2 whole groups. And then I'm going to have 1 left over, which becomes my denominator. Okay, and you can see I've done a bar model here to represent that. We've got the 7/8, add the 6/8, add the 4/8, so in a slightly different order. Okay, why don't you then have a go? We've got your turn over here. Have a go at these questions. Think about step 1, lowest common denominator. Step 2, convert. Step 3, add. And step 4, either simplify by dividing or turn it into a mixed number. Have a go, pause me, and then I'll reveal the answers. Okay, so for this question here, I would have turned 5/9 into 10/18 by multiplying by 2. And then that would have been 21/18 or 1 3/18. You can simplify 3/18 into 1/6 by dividing both the top and the bottom by 3. Sorry, I've got a road cat again, bear with me. So sorry. So then for this one, I would have probably changed those all into 12ths, I think. Yeah, divided this one by 2 to get 12ths. This one, I would have multiplied by 2 to get 12ths. My answer would have been 26/12 or 2 and 2/12. 2/12 can be simplified to 1/6. Okay, right. I've got a bit of a spicy problem here. We're going to read it together now. So I've got my R with a tick there, and then we'll look at how we might tackle it. So Eva has some bottles of lemonade, water, and apple juice. The bottles have a mass of 3 kilograms altogether. The bottles of water have a mass of 7/8 of a kilogram in total. Each bottle of lemonade has a mass of 11/16 of a kilogram, and then Eva's got 2 of those. How much do all the bottles of apple juice weigh? Quite a lot of information in that question, and quite a lot of kind of steps to work that out, it looks like. So let's have a look again. Maybe you want to pause me here and just think about how might you answer that question, and then we'll tackle it together. Okay. So if we go on to this next slide, the next thing I've done is I've underlined what I think is the key information, our second step in rucksack. So I've underlined kind of our numbers and what we've got of each of the water, the lemonade, and then what the question's actually asking us. Now, the question wants us to find out how much all of the bottles of apple juice weigh. But to do that, we're going to have to do a few steps before. So I'm going to do something. So I've underlined it all now or highlighted. So just reading through the question again, this first bit's really useful. So the bottles have a mass of 3 kilograms altogether. So I know that's what they are in total. 3, I'll put my measurement in there as well, 3 kg. And then I know that if we've got lemonade, water and apple juice, that's going to be, I've got lemonade, add water, add apple juice. I'm just doing letters to make it easier. Add apple juice equals 3 kilograms altogether. Okay, now again, if we look at the information I've got, I know that the water is 7/8 of a kilogram. And I know that my lemonade is 2 lots of 11/16. Okay, so if I just show you my bar model that I've drawn, you can see I've got the water is 7/8, our apple juice is what we don't know, and my lemonade is 2 lots of 11/16. Well, do you reckon you guys could work out what 2 lots of 11/16 could be? Of course you can, because you can just add those two together. We know the denominator will stay the same, so it will be 11 and 11, 22/16. So that's what the lemonade is, 22/16 of a kilogram. Okay, so I've got 22/16, add 7/8, add apple juice is going to equal 3 kilograms. Okay, well, again, when I'm adding fractions, I'm going to want my denominators to be the same, aren't they? So looking at my denominators so far, I've got 16 and 8. Both of those numbers, I could do my 8s and my 16s. 16 is in both times tables, but actually I prefer it smaller. And if I look, I could definitely, to turn 16s into 8s, I could divide by 2, and I could divide my top numbers as well, couldn't I? So I could do 22 divided by 2 is going to be 11. And the 16 divided by 2 will be 8. So 11/8, add 7/8, add my apple juice. That's all going to equal 3 kilograms. Now, a bit like before, now I've got a whole number as my answer. But actually, I think I prefer it. If I have everything as a fraction, it makes it a lot easier, because all I have to worry about is my numerators and adding and subtracting those. So if I wanted to turn 3 kilograms into an improper fraction, what would I do? Well, I know my denominator, I want to be 8, don't I? So if 8/8 are the same as a whole, we know that, don't we? How many would 3 wholes be? I'd do 3 times 8, which would be 24. So I know 11/8, add 7/8, add something equals 24/8. Well, let's work this out. 11 and 7 is 18. 18, add the apple juice, is going to be my 24/8, my total. What would I add to 18 to get 24? You tell me. Hopefully you went, well, I know 24 take away 18 is 6, or maybe you counted on. Whatever it is you might have done, 6 should have been your answer, which means 22/16, which is my lemonade, which is the same as 11/8. Add my 7/8, which is what my water is. Add my 6/8 would equal 24/8 or 3 wholes, which would mean my apple juice must be 6/8. Okay, so can I simplify that any further? Before I think about my measurement, adding that on, can I simplify 6/8 anymore by dividing? Hopefully you went, they're both in the 2 times tables. So I can divide both by 2, which would give me 3 quarters. 3 quarters of a kilogram. That's the measurement we're using, isn't it? We don't want to leave that blank, otherwise people might think we're talking about hot dogs or chocolate or something like that. So the answer to the question, how much do all the bottles of apple juice weigh, is 3 quarters of a kilogram. Okay? Right. I'm going to leave it there then. What I'd like you to do for me is, once you've finished this, come on over. I've got a very short video clip for part 2. It's just one extra style of question and then some fluency for you. And then all the activities will be on the website as well. Okay. Well done, guys. That was spicy. That's definitely given my brain a good workout. All right. I'll see you in a little bit. Bye-bye.